Hello guys, I'm Nithish from Codezilla community. I'm the technical lead. And today in this video, we'll be talking about deep learning and why deep learning. This is just an introductory part. And this video composes of a lot of interesting topics on deep learning. And later on, we'll be learning more about those. But let's just get ahead into the basics. So why deep learning, you could ask. Deep learning and why do we care about it? Because that's why you guys are here in this video. Specifically about deep learning, let me answer that by actually going back to the traditional machine learning, like from the core of it. Algorithms, we know that machine learning uses algorithms since deep learning is like a subset of the machine learning entire topic. And deep learning is more like into which we have these traditional new set of rules that we are going to talk about. For example, I have in front of you a few facial features, a low level feature, a mid level and high level. So what's the low level? These are just lines and edges, as you guys can see, but the machine doesn't know it's just lines and edges. It just recognizes it as an image data and collects data on it. On the right hand side, we see nose, face and mouth all sort of clumped in together. We as a humans have perceived faces, which means we have seen faces and we know their eyes are parallel to each other and nose is above the mouth and all that. So we could figure out a face from the mid-level features, but a computer doesn't because we haven't trained it to show it how the face looks like. So instead, what we are going to do is for it to classify a face properly or even recognize a face properly, we first train the machine learning model with multiple nose, eyes, and mouth so that it can easily identify it when we send in a full face, like the high level feature beside us, the full facial structures. So let's just go to the very first basic fundamental structure of a neural network, which is a perceptron. Perceptron is a single neuron. Here it is right in the middle. It's a single neuron network which takes input and gives an output. These are nonlinear. Nonlinear means they do have an x and y, so that's their nonlinear. Linear is just an x or an y. So nonlinear functions. This is one of the nonlinear functions. We take x, y, x2, xm, and then keeps going to n number of times. Here we have taken example xm, and then it goes through a summation process, which is the formula which you see in the side, which is it's a quite easy formula: x1 cross w1 plus x2 cross w2 and etc. up to the m digits, and g is that activation function. This is a simple formula. And as I talked about, it's a fundamental structure of a neural network. What is a neural network, right? And neural networks means in machine learning, a computer has his own structure of layers. Let's say it has its own network of learning. So when we as a humans, we have perceived a face from her childhood. We know that the eyes are parallel to each other, and when we see someone with a different structure other than our parents, we know that this could also how humans are existing, because at a very young age we could only recognize few faces. But a machine doesn't know that. Machine has to learn over time. It can choose any kind of path. For instance, if it has to learn about cars, it could learn from the tires and then move up to way of the body of the car, and then it could learn in a different network, which is just a line connecting multiple layers. Let's say one layer is about tires, one layer is about the outer structure of the car. So it could take a different path of learning. The path of the learning for a computer, for our algorithm code, is this neural network in simple way. And you could just read through this. As I mentioned, just a basic definition of it, nothing much to confuse about. So activation functions, let's go back to the neural network. This is a very basic neural network which we were looking at. So here you guys could see it's just 3 input, 1 linear path, and then we get an output. So in activation functions, we usually never get a single output or a single input. Let's say we want multiple outputs. So that's the reason we use activation functions. The very basic one is sigmoid function. Sigmoids, in this place we talked about sigmoid function. We'll be talking about sigmoid function because right now we are moving into the linear part of the activation functions. We could see that g of z equals 1 by 1 plus e power minus z, but you don't need to go to the math part. The actual code is in this tf right below us, tf.math.sigmoid. That's all you need to type in the actual deep neural network TensorFlow code. So sigmoid is a more common nonlinear activation, but like it's most used because of the how effective it is on giving out the data. And hyperbolic tangents are very code specific and not used quite often, but it is a very good activation function for the let's say there's a huge difference between the inputs. Let's say there are two extreme inputs. It's definitely able to find a threshold value for both. So those kind of codes require that, but we will be mostly using sigmoid as well as ReLU. ReLU is very versatile. It's the way it functions. It splits the regions, like it finds a maximum point and a minimum point, and then we all know above zero means this array region, and below zero is this region. So that's how it identifies or separate the needed data, which could be here or here, like wanted data and unwanted data. We'll be looking at that later on this slide. Yeah, so right here, activation functions. So importance of activation functions. Like I said, it needs to predict. An activation function needs to predict, needs and helps to predict in the actual values and gets rid of the garbage data. Activation functions is to introduce the non-linearities in the data that is actually important. So let's say the red dots are important, the green dots are not important. Actually, let's the green dots are important, and the red dots are not important. But the green layer, the shaded region, is the one which we need to predict our neural network, which means to predict our output. You could say that why we do have red here, but we are losing some data on the red region of the green dots. So in that case, when we use a linear function, just like I said, like I talked about ReLU or hyperbolic, those kind of which separates the regions. Since ReLU, like I said, it separates the regions. You get loss of data. We lose data. We don't want to lose data. We worked hard on getting all this data. We need to get rid of this. So that's the region we have developed. I mean, the deep learning scientists have developed over time to actually only identify the wanted data, no matter where or which region it is, because all data is important. Let's say this blue line, it could be even here. We never knew because the red region could actually cause some inequalities to actually draw its own threshold in this point. So in order for us to get a true value, this is what it is. So this is what we are working on, and we'll be working more about this loss of data and how actually we train a machine learning later on. So let me start by giving you an example of a perceptron. So a weight. So there's let's say there is weights. The weights is this yellow line right here. So the summation function, and then we have three inputs. So 1, 3, and minus 2 passes through the summation. W is represented like a matrix. That's why it's 3 and the matrix symbol and 2. So we do a matrix multiplication over here. X transpose XT, we know that. X transpose. And this is because it's a 2D matrix, so that's why we have two variables. It's not in 3D. Pretty simple. We are finding the dot product of this 2D thing. And we plot a graph. So we plot a graph. This is the basic equations, and we all know how to plot a graph is by equating it to 0 for x1, and then equating it to 0 for x2, and then we join the dot and we get this line. So you could see it is slightly away from the center, but that's all right because our example requires this particular equation. And this is where the lines are drawn. And this is the region prediction. So blue and green, because we cannot determine which is the positive or negative. We just have one input. So that's how the machine learns. So we have multiple inputs. We know which is good, which is bad. Like for example, if we're going to pass, we should know the pass mark. So if this is 50, the below it is like fail, and then the above it is pass. Multi-output perceptron. So dense connected. What does dense connected means? We have multiple connections of the two layers. So this Z1 and Z2 are the passing weights, let's say. Let's just call it passing weights. And we have three, not just three, we have multiple inputs. Because XM is up to M. So right here, let's take three inputs. But imagine there are multiple inputs, and then we have every possible way. This X2 can have two different paths. So the combination of this and this could give different output at this, and XM could give a different output. So that's the reason. This is like a mid layer, very basic layer, single layer network, and then we get two outputs over here right now. And then this formula is a mathematical representation, but in TensorFlow you just do this. You import TF, which is the two layers which have been presented right here. Layer is the variable, and TF dot layers dot density units 2, because there are 2 units. It's 2 simple layers. That's it. And moving on to single neural network, the most basic neural network of all. And this means that we uh, we have inputs and then we have outputs. We have determined that we are going to get just 2 outputs, and they're going to be determined to 2 outputs. And then I have mentioned hidden layer. So the hidden layer is the one which we don't initialize or we cannot interfere with. So we have inputs X to XM, and then a dense network. Like I said, it has 3 possibilities: X1 to Z, and then X2 to Z. So everything has 3 to 4 possibilities to actually go on. And imagine that for up to n number of times. So W1 and W2, that is the weight. That this region, since how complex it is, let's just in a simple way, I'll say this amount of connections is having, that's the weights of this. We need to balance it, of course, but right now that's the weights. So we are going to name it as W1 and W2. Okay, this is the hidden layer through which it passes on, and then GZ1, GZ2, are like every small activation functions for every single layer, hidden layer. We cannot access this hidden layer. This is the network that the computer creates for you to give you a specified output, Y1 and Y2. Okay, and we have a single layer that feeds in a single output layer. This is going to be hidden layer and not directly enforced, which means you cannot make this layer. We are not adding or making this layer. So that's it. That's about it. Okay. Application of Perceptron. We could discuss a problem right now about an application. Will students pass or fail? So we have a small amount of data. The green dots are the pass. We know it's pass. The computer doesn't. And we have plotted a graph. Hours spent on a final subject, number of lectures you attend. So depending upon that, let's say you have spent 20 hours, you got a pass mark. And the people who have spent less hours and less amount of lectures, and they're definitely they're going to fail. We know this, but the computer doesn't. So we train with this small amount of data, and I place this here. So yeah, this is the small hidden layer. We take 2 inputs first because you are 4,5. You over here, your plot is 4,5. This is our, let's say it's an example to pass on through this, and predictor is 0.1. 0.1 is kind of not good because it's 10%, and you know where you fall if you're 10%, you don't pass. So the computer has given a wrong prediction. How do we know that? Because you have passed. You are in the pass region. We are in the pass region. We know that. but the computer doesn't. It just predicted 0.1 because it did the math functions that, like we discussed, it went through the activation function and got a value of 0.1. It approximated it to 0.1 as its own value through mathematical equation. So how do we make it predict 1? Because your pass means 1. 1 is 100% over here. It's that's how the predicted values are. It's not in percent, it's directly in numeric value. So divide by 100, anything, so let's say 100 divided by 100 is 1, right? So that's it. We'll just summarize a little bit. We learn about importance of deep learning. Like I said, we train every single small aspects and then we clump them together and the machine learns it much effectively. And Perceptron is a single neuron structure. It's just a simple neural structure, non-linear, and we'll be learning more about like complex neural structures in the upcoming video later on. Please stay tuned for that. You might have even a hands-on session, and I could show you guys the actual working of it. So we did learn about activation functions, sigmoid, hyperbolic, and ReLU. These are very basic activation functions. Definitely ask any queries or doubts. This is about me, and this is my LinkedIn. It's probably in the description box as well. And I'm part of Codezilla community. Join us at Codezilla. All these socials available. You can definitely hook us up on Instagram, and we'll definitely make sure to answer all your queries or doubts if you have any. And join our portal, community portal. And thanks for watching this video, guys. Like, share, and subscribe. Thank you.